Good morning, students. So, this is our fifth episode. So, if you missed the previous episode, you can go through the channels and you can see that. Okay, we are discussing on the chapters light. So, this is our fifth episode and topic is spherical mirror. The spherical mirror already we discussed in the previous episode about what is spherical mirror, how many type of spherical mirrors are there, and some common terms. What is known as aperture, what is pole, what is center of curvature, and what is radius of curvature. Up to that was in my previous episode. So if you missed, you can see that. Okay, so subscribe the channel and also click on the bell icon to get all the notification and share it with your friends. Okay, to understand physics. Okay, more means easy, very easily, and it is nothing but a fun. If you can understand, this subject is very easy, that I can assure you. So now the spherical mirror. So we are moving ahead in this episode. So now the important topic we will discuss. What the important topic today, that is known as principal focus. Okay, what do you mean by the principal focus? Okay, so before we discuss about the principal focus, let us understand what is principal axis. Okay, what is principal axis? So what do we know? Suppose this is the mirror, spherical mirror, this is the concave mirror. Okay, so this is what? The center of curvature, and this is the pole of the mirror. This is the center of curvature and this is the pole of the mirror. So if you draw a straight line that joins the center of curvature and the pole of the spherical mirror, so this line is known as the principal axis. Okay, so this line is known as, very important term. Okay, so that is known as the principal axis. So this line is known as principal axis. Okay, so this is known as the principal axis. Now suppose this is convex mirror. Okay, so this is what? Radius of center of curvature, and this is pole. So in this case, this will be the principal axis. So the straight line which joint the center of curvature and the pole of the spherical mirror is known as the principal axis. So I think it is clear now what is principal axis in case of the both type of mirrors. Okay, so now we will discuss what is principal focus. What is principal focus? Okay, so for the two type of mirrors, okay, the two type of incident will occur. Okay, so let us first discuss about the concave mirror. Okay, so this is the concave mirror. Suppose this is the principal axis. Okay, and a parallel beam of light, incidents, parallel beam of light, incidents. These are the parallel beam of light that incidents on the concave mirror, MM1. Okay, so it will be reflected by the mirror. So it will be reflected here. So the reflected ray will incident on a particular point. Okay, after getting reflected by the mirror, the reflected ray will meet at a particular point on the principal axis. So this point is known as principal focus. This point is known as principal focus. This point is known as principal focus. Okay, so when a parallel beam of light parallel to the principal axis incident on the concave mirror, then after getting reflected they will meet at a particular point on the principal axis. That point is known as principal focus of that particular concave mirror. So all of you have understood what is the principal focus of concave mirror. Now let me discuss the principal focus of convex mirror. The principal focus of convex mirror. Suppose this is the convex mirror. This is pole. This is the principal axis. These are the parallel beam of light. Now it will be deflected like this. So if we extend the rays at the back side of the mirror, then that point on the principal axis is known as the principal focus of that convex mirror. Okay, so what is the principal focus of the convex mirror? If a parallel beam of light incidents on the convex mirror, then it will be deflected back, but reflected rays will not meet on the principal axis. But if we extend, okay, the reflected rays at the back side, then on the opposite sides of the mirror it seems to be meet at this point. So that point is known as the principal focus of the convex mirror. So students, I think this concept is clear. So what is principal focus? So when a parallel beam of light, okay, with the principal axis incidents on a spherical mirror, then after getting reflected, the point on which they actually meets or the point they appears to meet, okay, on the principal axis, that point is known as the principal focus of that particular type of mirror. In case of the concave mirror, it will actually meet on the principal axis, okay, and in case of the convex mirror, it appears to meet on the principal axis. No rays will actually meet on the principal axis actually, okay. So this is known as the principal focus, and the distance between the principal focus and the pole of the mirror is known as the focus length. Focus length, okay. The distance between the principal axis and the pole of the principal focus and the pole of the mirror is known as the focus length, okay. So what is the focus length? The distance between the principal focus and the pole of that particular spherical mirror is known as the focus length, okay, of that particular mirror, okay. So we have learned, okay. Now this is what, suppose this is the mirror, okay. So if a parallel beam of light incidents on it, so after getting reflected back, it will meet on the principal axis. So that is known as the principal focus. Now the distance between the principal focus and the pole of the mirror is known as the focal length. That is known as f. Okay, this is known as f. So there is the relationship between the principal focus and radius of curvature. Okay, so there is a relationship between the principal focus and radius of curvature. Principal focus length, suppose it is f, and radius of curvature is r. So f is equal to r by 2. So this is the relationship between the principal focus and radius of curvature. So the sum may come. Okay, so if the radius of curvature of a spherical mirror is 40 cm, what will be the focal length of that mirror? So what is the formula? F is equal to r by 2. So it will be 40 by 2. Okay, so it will be 20. Okay, F is equal to r by 2. Okay, so that is the relationship between the radius of curvature and principal focus. Clear? Now we will discuss about some ray diagrams. Very important for the exams also. This type of questions often come. You have to complete the ray diagrams, okay, of the spherical mirror, both in case of the concave and convex mirror. So first of all, you can identify this mirror. This is a concave mirror. You can identify it is a concave mirror, okay, and this is now what? Nothing but the principal axis, okay. And suppose this is the ray, incident ray. Now we have to complete the ray diagram. So what will happen? It will be deflected and it will pass to the principal focus, okay. So that will be the direction of the reflected ray, okay. So when a ray of light parallel to the principal axis incidents on a concave mirror, after getting reflected, it will pass to the principal focus. So clear to all of you? I think this is clear. Same thing Okay, in case of the convex mirror, in case of the, suppose this is the principal axis. In case of the convex mirror, this is the principal axis. Okay, so a ray of light is parallel to the principal axis, incidents on it. So it will be reflected at this path. Okay, it will not meet on the principal axis. Now, if we extend it at the back side, so it will meet here. So this will be the ray diagrams. Okay, so in case of the convex mirror, this will be the reflected ray, and okay, if we extend it, it will meet on the principal focus on the principal axis. Okay, so this will be the ray diagrams. Now, suppose this is what type of mirror? This is concave mirror. This is the principal axis, this is pole, this is F, and this is center of curvature C. Okay, suppose one ray of light coming through its principal focus. Okay, then after getting reflected, it will be parallel to the principal axis. Okay, if a ray of light will not parallel to the principal axis, it is coming through the principal focus and incidents on the mirror. Then after getting reflected by the mirror, the reflected ray will be parallel to the principal axis. Okay, you can find the similarities. You can find the similarities of the picture. Okay, so when it is reflected and it will meet at the principal axis. Okay, and here it is just reverse the direction. If the rays coming to the principal focus, after getting reflected, it will be parallel to the principal axis. Okay, so very easy to understand and very easy to remember. Now the same thing in case of the convex mirror. In case of the convex mirror, suppose this is the ray of light. If the convex mirror is not there, it seems to meet at the principal focus. So after getting reflected, it will be parallel to the principal axis. Okay, it will be parallel to the principal axis. In case of the convex mirror, if the ray of light not parallel to the principal axis, it suppose seems to, if the mirror is not there, it suppose seems to meet at its principal focus. But after getting reflected by the mirror, the reflected rays will be parallel, okay, to the principal axis. Okay. Now, suppose this is a concave mirror. This is a concave mirror. This is the principal focus and this is the center of curvature. Now, if a ray of light passes to the center of curvature, and incidents on the concave mirror, then after getting reflected, it will be reflected back to the same path. Okay. So if a ray of light passes to the center of curvature, after getting reflected, it will be back to the same path. Okay. So this is so if it is like this from the principal focus, then it will be parallel to the principal axis. But remember, if it is to the center of curvature, then it will be back in the same path. So clear to all of you? Now the same thing for convex mirror. The same thing is for convex mirror. Suppose a ray of light coming and it is principal focus and it is center of curvature and appears to meet at the center of curvature. Okay, then it will be also reflected in the same path. Okay, clear? It will be also reflected in the same path. But in the earlier cases, what we have seen, that ray of light, it appears to meet at the principal focus then the reflected ray will be parallel to the principal axis. But if it appears to meet at the center of curvature, then what? Then in the same path it will be reflected back. Okay. So next one, in case of the concave mirror, suppose this is the pole of the mirror and this is the principal axis. A ray of light incidents directly on the pole. So here it will make an equal angle just like the reflection, if you can remember. Okay, and it will be reflected back in this path. Okay, so it is the incident ray. If it incidents at the pole, then it will make an angle, equal angle with the center of curvature, and it will be reflected back to this path. Okay, in case of the concave mirror. And in case of the convex mirror also, if it incident on this, so it will be reflected back at the same path. Okay, so the ray diagram is almost similar in case of the concave and convex mirror when the ray will meet at the poles. Okay, so these parts are very important for your board exams also or any other exams also. You have to you will be asked the question, complete the ray diagram, okay, of the spherical mirror. Okay, so you have to understand whether it is parallel to principal axis, or it is passing to the principal focus, or it is passing to the center of curvature. Okay, so if it is passing to the center of curvature, then what will happen? Then it will be reflected in the same path. Okay, and if it is passing to the principal axis, principal focus, then it will be reflected parallel to the principal axis. Okay, so that you have to remember, and you have to be very careful when you are writing the answer. Okay, so I think this slide will help you to clear your doubts, okay, regarding what happens if a ray incidents on two type of mirrors, spherical mirror, okay, and in which direction they will be reflected back. And in my next episode I will discuss about the images formed, okay, by the spherical mirror. Images formed by the spherical mirror. In my next episode I will, if the object is placed in different position, what type of images, and the nature of the images, and also the position of the images. So the students, subscribe my channel and also click the bell icon to get all the notification, and share it with your friends, okay, who want to clear their concept in physics, these topics, or who want to sit in the board examination. The board exam special episodes are also coming shortly. Okay, and also subscribe my channel. So I think it will be a very helpful for you, and physics will be a fun for you.